This video is Matthew C. Lesson 26, Repeated Factoring of Polynomials. So we have seen before that we can have more than two factors when we pull out a number from all parts of the polynomial before we factor it. So if we had something like 2x squared plus 6x plus 4, we see that every one of these has a factor of 2. So we can pull out that factor of 2, and that will make it easier to continue factoring this one. So now we are looking for factors of 2 that add up to 3 because we no longer have a coefficient in front of the x squared to worry about because we took a 2 out of everything. Remember, when we factor out, it's like we're dividing each of these terms by 2. So 2x squared divided by 2 leaves us with x squared. 6x divided by 2 leaves us with 3x. And 4 divided by 2 leaves us with 2. So we could put this back in by distributing this 2 through all of these terms, and we would get back to where we started. So now, again, we're looking at factoring this. We want to keep that 2 in front because it didn't go away. We can't just make it disappear. We just factored it out in front of the parentheses. So now we want factors of 2 that add up to 3. So we're going to put our parentheses here of our 2 factors. We know that we have an x in front of both. We have a plus sign here, so we don't have to worry about signs. And now 2 plus 1 would give me 3, and 2 times 1 will give me 2. So these are factors of 2. They multiply together to give me 2. And when I do them with the x's from the outside and the inside, they will add up to the 3x. And then our first ones are x and x becomes an x squared. So this is more than 2 factors. So it's repeated factoring of polynomials. We pulled out one of the factors first, and then we factored what we had left. It's somewhat similar to when we do a factor tree. If we had something like 48, and I said factor it completely, you might say, well, 48 is 6 times 8. But you can't stop here because 6 and 8 aren't factored completely. We can go a little further that 6 is 2 times 3, and 8 is 2 times 4. And then here, we're not even down to our prime factor yet either because 4 can be factored one more time. So I like to pull all of these down so that I have them all in the same line, and 4 is 2 times 2. So then this is the complete factorization of 48. So when we say in the directions completely factor or factor this completely, that means you want to get down to all of your prime factors. So right here, this line would be our prime factors. If instead we had taken this and said, okay, well, we can do 2x plus 4 times x plus 1, and here my last term would be 4 times 1. That would give me 4. The outside would be 2x, and the inside would be 4x, and that would add up to 6. And then the first terms would add up to this. So this is factored, but it's not factored completely. And what's the difference between these two lines is right here. This factor right here in the parentheses can be factored more. I can take a 2 out right here and make it 2. When I pull a 2 out of 2x, I have an x left. When I pull a 2 out of 4, I have a 2 left. And then this factor stays the same. So there's really 2 methods to factoring this. I prefer to pull the 2 out first because this seems easier to factor. But if you factor to here first, you just have to look at each of these factors and make sure there's nothing else that you can pull out. If there's something else to pull out, then you need to do that because this right here is not factored completely. It's like stopping at this line. You're close, but that 4 can be factored again. This 2x plus 4, you can pull out another factor. So let's look at a few examples. Factor x to the 4th minus 81 completely. So when we want to factor x to the 4th minus 81 completely, I see a perfect square and a perfect square. So I'm going to take, and the difference between them. So I'm going to do x squared, that square root, and I'll do a plus 9 and an x squared minus 9. I have this that multiplies together to be negative 81. This multiplies together to be the x to the 4th. And the outside and the inside will be a negative 9x squared, positive 9x squared, and those will add up to be 0. But this right here is not factored completely. I see something else I can do. When I look right here, I have 2 squares and the difference again. This one is 2 squares, but there's a plus. So this is prime. You can't factor this one again without going into square roots and imaginary numbers. So we can't do this any further. But this one right here, we can do the difference of 2 squares again. It will be x plus 3 and x minus 3. Now I look, if I have an x all by itself, there's probably no other factor I can pull out. And then this x squared plus 9, it is 2 squares, but it's a plus in between, so I cannot factor this any further. So now this is my final answer. That is factored completely. What about 3x to the 5th minus 48x? Let's factor this one completely. Well, I see an x in both parts, so I'm going to pull that out first. And then I'll have 3x to the 4th minus 48. Now I see a 3 here. Is this one also divisible by 3? It is. So we're going to want to take that 3 out as well. When I take it out, I need to multiply it over here by this one. Because it's 3 and an x, I can just write them next to each other. When I divide the 3 out here, I'm left with x to the 4th. When I divide the 3 out here, I'm left with 16, I believe. So now, can I factor this? Yes, I can. I can keep going. So I'm going to move over here as I write 3x, and it's a perfect square and a perfect square. So I can do the difference of 2 squares. I'm going to have a plus and a minus. Now this one, I can't go any further, but this one, it's still 2 squares and the difference. So I can do that one even one more time. So I leave all this that I can't factor anymore, and I write out the factors for this, x plus 2 and x minus 2. So now I have so many things that I pulled out, but that is factored completely. All right, 3x squared y minus 9xy minus 30y. What do you see to pull out first? I see a y everywhere. So I just want to take that out first. So 3x squared minus 9x minus 30. Now I'm looking and I see all of these look divisible by 3. So I'm going to pull out a 3 with my y. And now this one leaves me with x squared minus 3x minus 10. Now I don't see anything else I can pull out, and this looks like a fairly simple one to factor, so let's see if we can figure out what the factors are. I have an x at the beginning because there's no coefficient there. I'm going to have a plus and a minus, so I'm going to have to figure that out in a minute, but what can I multiply together to give me 10 that when I subtract it, the difference between the two would be 3? So 10 and 1, when I subtract that, it's 9. How about 5 and 2? 5 and 2. When I subtract, I get 3. So I know that I'm at 5 and 2. And then I'm looking for a plus and a minus where they add up to a negative 3. So if they're adding up to a negative 3, I want this one to be negative, the 5 to be negative, and the 2 to be positive. So just to double check, the outside would be 2x minus 5x. That would give me the 3x. When I multiply the last ones, that would be negative 5 times times a positive 2. Negative 5 times a positive 2 is a negative 10. So this is factored completely.